Chapter 3 is all about differentiation rules, and we're going to look at a lot of different things. So chapter 3, differentiation rules. So we're going to start with the power rule. And I do remember one thing that we looked at, and this is part of power rule as well. The square root of x, some time ago we said, we know that this is the same thing with x to 1/2. So we differentiated this, and I think we carved it in stone. If I remember incorrectly, we can show step by step the steps, is 1 over the square to the square root of x. Do we remember this, or because this is extremely important? Do we remember this, or we want to prove it? If we say we want to prove it, then we have to prove it with a limit. So if f of x equals the square root of x, and then f prime of x equals the limit as h approaches 0 from the difference quotient, f of x plus h minus f of x divided by h. So can anyone confirm, did we do this? I have another calculus class, which is for social sciences, and I don't remember if I did this in your class or with them.
I think we did it because it's in the notes.
Okay, so then I don't have to do this. So this would have been the limit as h approaches 0 from the square root of x plus h minus the square root of x divided by h. And we did it step by step, and we got this result by rationalizing, because of course this is 0 over 0. Okay, so this was part of the power rule, but the power rule for any power, including 1/2, so x to the nth power, I'm sure many of you remember this, is we bring down the power and we multiply by x raised to power n minus 1. I should also multiply here, continue to multiply by x prime. There is no need to multiply by x prime because the slope of y equals x is 1, which means x prime is 1. Okay? Please ask anything if you have any questions. The reason why I want to put this in here, you can say, but this is redundant. Why would you put it here? It's not there. The reason I am going to use it for now and just write x prime is 1 is for what follows next after sections 3.1 and 3.2. Okay? So please keep that in mind. We don't write it because it's 1. Okay, now let's say we want to differentiate a sum or a difference. So if I want a function plus another function prime, all I have to do is f prime plus g prime. If it happens that this is a difference, then this will be a difference here. So if I want to differentiate a sum or a difference, that's all I have to do. If I want to differentiate a constant, any number prime doesn't have a rate of change. So any constant prime is 0. I would like us to look at some examples now. And of course, if I have a constant multiplied by a function and I want to differentiate, this is the same. Remember, this is a limit, right? So constant can be put in front, and then I multiply by f prime. Okay, so I would like us to look at 3.1, and feel free to choose anything you want from 3, anything that fancies your taste from 3 to 32. And this is in 3.1. So before you choose one, I would like to also talk about the derivative of e to the x. That's the last thing that we need to discuss before we choose problems. Or we choose a couple of problems and then we go back to e to the x. Can anyone decide for us or say anything? Anyone? Is anyone paying attention? Anyone with me?
I'm
Yeah.
opening up the textbook right now.
Okay.
I'm trying to open up the textbook too.
Okay. Okay, that's fine. So till you find something, okay, it's just 10 minutes. So till you find something, I'm going to talk about this. This is one problem, one function that I would like to go back to the limit of the difference quotient. So this is our function, f of x, exponential function, natural exponential function. And we want to determine f prime. This is our question. So how much is e to the x prime? This is what we are trying to discover now. And we know that with the difference quotient, the limit of the difference quotient, we will have the limit as h approaches 0 from f of x plus h minus f of x divided by h. And this is limit as h approaches 0, e to x plus h minus e to x divided by h. Okay, so here I would like to review with you what does this represent. So when we have a base raised to a power that is a sum, n plus m, n and m, what does this represent? Is there another way of writing this? Anyone?
Is it a to the n times a to the m?
Great job. Thank you, Derek. Perfect. So normally you would say, well, but we were taught to look this way. Yeah, but this is the same thing. This is a dynamic relationship. This can turn into this, and this can turn into that. Why do I need this? It's because of that. So now I'm going to circle this so you know where I continue. So I have limit as h approaches 0 from, as we said, e to the x times e to the h minus e to the x divided by h. Can anyone suggest anything to do at this point? Any suggestions?
Did the d, the x, the e, the h, did they need to be in parentheses?
No, it's a product. It's a
Just want to make
product.
sure.
Yep, no, it's a product. You can put them in parentheses, it's not wrong, but there is no need. We don't put parentheses here. It's not incorrect. So what do you think I'm going to do? Anyone?
I'm gonna
Subtract the e from to the x minus the e to the x.
You mean factor. Good.
Sure.
Does it depend, does this, which is a common factor to both terms at the top, does it depend on h?
No.
No. So it's a constant. It can go outside all the way. It's a constant for anything that depends on h. So e to the h minus 1 divided by h. Very soon we're going to learn a theorem, but I cannot present it today because we don't have enough knowledge. So now I want to look at this. And our only possibility is, at this point in time, very soon we will have other possibilities. I'm sharing my screen now. Okay, I'm going to put in y equals. I'm going to clear whatever. I'm going to make sure that the plot, I'm not going to graph, so I don't care. But I can go and turn that off. so it doesn't bother us. Okay, so I go back to y equals, and I will put in this function. Do not forget parentheses. I don't have h in the calculator, so I have to use x. So second e to the x, and then minus 1. This stands for h. Minus 1, and of course divided by x. I want to graph this function, or not graph it. Okay, I'm going to go to the table, and I want to be as close as possible to 0 from the left and from the right. 0.1. Okay, sorry. Oh, it says 5 minutes. Okay, 0.1. Then I'm going to say 0.001. Then I'm going to say negative 0.0000001. And then I'm going to say 0.000000001. And you got the picture. Can anyone tell us what is the limit of e to the h minus 1 over h as h approaches 0? What does it equal to?
1.
Thank you very much. Great job. I'm going to stop sharing now. Back. This is 1. So then the answer is e to the x. You will not very soon find another nicer function than this one. It's its own derivative. So the derivative of e to the x is e to the x. Okay, now I'm ready for you to pick problems so we can move on. Anything? Can dictate anything or pick anything, or I will.
What about problem 4, which is
Okay, can you dictate that?
find the differentiate the function g of t equals 5t plus 4t squared.
So 5t plus 4t squared, like this?
Yes.
Excellent. So this is a sum of two functions. We want to find g prime. So we know that this is a constant times a function. When I differentiate t, what do I get? It's like differentiating x a minute ago. What is the slope of t, or what is the rate of change of t?
Would it be x equals y?
So t prime is 1 times 5 is 5, plus we bring down the power and we multiply by 4, so this is 8 times t, and we subtract 1 from the power, and that's it. Any questions? Any questions? Y equals, this is x, sorry. I'm going to delete it, erase it in a minute. So minus x to 2/3. So this is slightly more difficult because of the powers being fractional exponents. But the procedure is identical. We bring down the power and subtract 1 from the power. So we have several notations that I would like you to get used to. One notation for the derivative is this. Another notation, the one that we used from the beginning. And here's another notation, dy over dx. This is what it's called Leibniz notation. The derivative of y with respect to x. We can also have the derivative of f with respect to x. So all these mean the same thing. Different notations. So then here you can write, if you want, dy over dx. You can write y prime. They mean the same thing. I have to bring down the power and subtract 1 from the power. On the side, if you want, 5/3 minus 1. Can anyone give us the answer?
2/3.
Yes, 2/3, awesome. So this is power 2/3. This is a minus. I bring down 2/3. And I have to subtract from 2/3, I have to subtract 1. I was just looking for my cup of water. So what do we get here? The power would be? Anyone?
Negative 1/3.
Great job. That's it. Okay, so let's also look at something like age of x, which is e to the x plus x to power e. The same question, age prime of x, or if you want, dh over dx, the derivative of age with respect to x. When I differentiate e to the x, what do we get? The friendliest function of all?
E to the x.
E to the x. Okay, sorry about that. Okay, 1 second to finish this. Got it, I got it. Okay. And then plus, I bring down the power and I subtract 1 from the power.